Hello everyone, this is tutorial 8 of Math 2000. Today I have 3 questions, so let's jump right in. Question 1. Let S be an open convex set of Rn. Let f be a function from S to Rm, so it's a vectored value function, and let f be C1. We want to show that given vectors x and vector a, that we have this expression, and we want it so that the remainder term r satisfies this. So this is to ask that the norm of the remainder term r is going to 0 faster than linearly. And this is what we want to show. Okay, so first thing is first, f is a function from S to Rn. So we know you have m component functions. And we know that f is C1. So therefore, each of the component functions fj from S to R are C1 themselves. And because each one of them are C1, we can apply Taylor's theorem. So we apply Taylor's theorem to each fj. And then by Taylor's theorem, we know that the fj can be expressed like this. So fj at vector x is equal to fj at vector a plus the gradient of fj at a. It should be fj at a dot vector x minus vector a plus the remainder term centered around a, order 1, because Taylor's theorem for order 1, at x. But specifically, this is the remainder term for the jth component. So I'm going to put a superscript j to remind us that it's the remainder for fj. And by Taylor's theorem, we know that the rj's, the norm of it, will go to 0 faster than linearly. So such that the limit as x goes to a, the norm, that's a f, should be r, the jth one, we put an x there, this goes to 0 faster than linearly. And this is the number 0. So we just now recall, we know each component satisfies Taylor's theorem, so we just bundle everything up together. So f of x is equal to fj at x for all your component functions. And each of the component functions satisfies this. And this is satisfied by each component function. So all we have to do is just move some terms around. So when we move some terms around, we then end up with fa plus, these guys form the total derivative. df at a dot x minus a plus r a1 at x. Because the remainder term for f itself, this can be thought of as the remainder term for each of the component functions at a1 x. So all we did is just move some terms around. So we're almost done. So now what we want to do is we want to check that. We want to check that this remainder term goes to 0 faster than the linear rate. So now check. This goes to 0, and here it's the 0 vector as x approaches to a. And I'll continue that in another video.